6.3 talks, or 6.2 talks about counting the elements. Which already has done with the other class. So I will just copy paste it from that other class. Page 144. Exercise 6F. So we have a Venn diagram. In this Venn diagram, you see a group that likes pizza, a group that likes quesillo, and you have two people that like pizza and like quesillo. And of course, you have those that like mathematics. As you can see, it's a lot. More than if you like quesillo. And then the first question A says, P intersecting with Q. What does that mean? That means everyone who likes pizza and quesillo. How many people in that specific class like pizza and quesillo? That's easy. Those two here. Simple. B and P, but not Q. That means if I ask the question, who only likes pizza, you like pizza only, nothing else, raise your hand. Only 7 people will raise their hand. Because these two like pizza and quesillo. My question was only pizza, only like pizza. C is just what we did, but in reverse. I asked the question, who only likes quesillo? So, only these 5 will raise their hands. That's it. And then I ask, neither in P or Q. So, raise your hand if you only like mathematics. So, these 6 people raise their hand. They do not like pizza and do not like quesillo. They only like mathematics. And then follow something a little bit trickier. All the elements, everyone who is in P. So I say, raise your hand if you like pizza. So, all of these raise their hand, meaning 9 total. Yes. And the number of elements. The number. And then we go to Q. Who raise your hand if you like quesillo? That's it. So these 5 students will raise their hand as well as these 2 students. Because I only asked, if you like quesillo, raise your hand. Boom. 7 people raise their hand. P with the union of Q. That means everyone. If you like pizza and if you like quesillo, raise your hand. everyone in these two circles shall raise their hand. Meaning 14. And you, everyone in the class, raise your hand. So that's everyone. 14 with 6, 20. And you, everyone. And P apostrophe. All right, starts to get interesting. Everyone who does not like pizza, raise your hand. Who does not like pizza. So 5 and 6. Oh, sorry, pizza. Yes, correct. 5 and 6. Not like pizza. So, another way of saying it is, raise your hand if you like quesillo and mathematics. Yes. The 6 is what? No. You don't like pizza or quesillo. You don't like pizza, P or Q. This Venn diagram represents those who like pizza and quesillo and everyone else. So those 6 people like something else. I don't know, something else. Anything else. Everything that's not in P. Everyone that's not in P. What do you mean? This is everyone else. So you like mathematics. You like biology. You like coming to school. Everything else. And anything else. And Q apostrophe. So everything not in Q. So 7 and this 6. 13. And that was it. Wow. This was so easy. What do you mean? Yes, but you have to write the letter and then the apostrophe, or I don't know what you mean. If you only write an apostrophe, not in what? Yes, that was 6.2, as well as 6.3. We did it in one exercise. 6.4, your answers, you will start to notice they will become like this. Give your answer such X, element of N, X is not an element of Z. You will start saying the answers will have to look like this. Of course. Why not? You're not practicing, so I have to give you more. Then you are practicing. So numbers in sets. 6.4. Wow. Easy. Before I was born, and I was born a long time ago, the world only knew of the W. Now, what is the W? Whole numbers. What are whole numbers? Whole numbers are a set of numbers ranging from positive 1 to infinity. Positive 1 as whole numbers. Yes? Afterwards, still before I was born, there came one person, and that person said, well, the number 0 exists. When you have nothing, it exists. It's a number. 0 is a number. And everyone thought that person was crazy. And eventually, many people, they were crazy themselves, and then formed N, which is the natural numbers. Now, what are the natural numbers? The natural numbers are the whole numbers. The only difference is you have a 0, 1, 2, 3, to infinity. That's the only difference. You have a 0. What? Infinity. Infinity is 0. How can infinity be 0? Infinity means a number so large you cannot count it. That's the positive infinity. And then, after everyone who thought the number 0 was crazy, someone even crazier in mathematics existed. He said, well, did you know that, that negative numbers exist? Did you know that? Everyone thought this guy was crazy. Negative numbers? What stupidity are you talking about? Negative numbers. How does it mean you have negative? How can you have negative? That does not exist. Z. Integers. And then the integers were invented. So what are the integers? Negative and positive what? Whole numbers. So, negative infinity, negative 3000, 0, 1, 50, to infinity positive. Correct. I mean natural numbers. Whole as in whole. Integers, natural numbers.
Can decimals be
Mm-mm. Natural numbers. Sorry?
Natural numbers consider 0.
0 is added.
Whole numbers not.
No. Then you have the integers. After that, it's the Q. So what are Q? Correct. And a good name for fractions in the mathematical term is called rational numbers. The rational numbers. Technically, they are fractions. Technically. Now, why do I say technically? Because rational numbers seven. Wait, you can divide that. You can a rational number, when you place it in a decimal, the number keeps, yes, repeating itself.
In natural number, not consider zero, a whole number.
Oh, right, no, correct.
Walang ganito, ewan ko. Pero explicando, era opposite.
My apologies. These were the natural numbers.
Great. Oh man. I get that in my head.
So the natural numbers are from 1 to infinity, and the whole numbers are from 0 included. So the rational numbers technically are fractions, but to take it a step further, the rational numbers, they keep repeating themselves. For example, 1 divided by 3 is 0.333333. The 333 keeps repeating themselves. That is why it's called a rational number. You might have fractions that become 0.135, and then they keep repeating again, 135, 135. That's why they are called rational numbers. They keep repeating themselves eventually. Yes? So rational numbers, you can use fractions and decimals who can repeat themselves. Afterwards, you have the irrational numbers. And that is everything else. And what is everything else? Those form part of the real numbers. Yes? So everything else. And what is everything else? Pi. That's an irrational number. Why is it irrational? Because the number in decimals, yes? Yes. This is everything else. Everything else. No, real numbers. Q is rational. So, irrational is everything else, because you know rational numbers repeat themselves in a fraction.
And rational numbers be negative?
Yes, negative and positive. Irrational, the same. Pi, the square root of 3. a number you will learn when you go to k. E to the power of x. It's irrational number. Yes, E, this guy got his own number. The name is Euler. He got his own letter. Euler, E, Euler. Numbers like the log function that you get in chemistry, irrational numbers. So the way,
So the pi and the square root and all that stuff are real numbers or irrational numbers?
they're irrational numbers. They belong to the real numbers. I'm going to explain it right now. So the way you look at it is you have the natural numbers. Outside of that circle, you guessed it, you have the whole numbers. So it's if in the natural numbers, it's also in the whole numbers. And then continuing, you have the integers. If you're in the natural number, you're also a whole number, and you're also an integer. Yes? After that, you have the rational numbers. And lastly, you have the rest of the numbers, which are the real numbers. That's how you look at it. So if you look at this exercise, -6 does not belong in the natural number system, because the natural number system does not have negative numbers.
But this here, so that means that real number is irrational number is the same.
No, real numbers technically mean all the numbers. It means all the numbers. Irrational numbers are part of the real numbers, because we classified all the types of numbers, and what is left? The irrational numbers. Those are left. So those are part of all the numbers in total. So we classified all the numbers. And everything that's left is here. All that's left. But everything is part of the real number system. Everything. Yes? Those are, sorry? Correct. It's an irrational number, but it's also a real number. If you say, what is pi? Irrational number, to be very specific. But it's part of the real number system. Yeah, it's also correct. I can say -6 is a real number. Yes, it's a real number. But I can also say it's an integer. Yes, it's also an integer, to be specific. Yes? Yes. Yes, as you can see, square root of 5, x at natural numbers, x at integers, x at q, and only a vinkje at dr. It's only part of the real number system. Yes? Now that you know that, you will get answers, for example, stating And then they say, your answer is an element of, let's give an example, Z. Then you should know what that means. Yes. Less on your phone and more in your books. And then you will know. Yes. No. You have different answers. So you have to write a set of numbers. Z represents integers. Integers represent whole numbers ranging from negative to positive. So 0.5 doesn't count because 0.5 is a rational number. So I'm only looking for whole numbers. For example, -1, -10, 5 or 3, 5. I'm looking for those numbers. No, you have to write all the answers. For example, one answer is 1. X is 1. I need, when I place 1 in X, my answer is between 3 and less than 10. This symbol means everything between 3 and 10. And now I'm going to place a 3, making it more difficult. So you have to calculate. And I say the answer has to be an integer. Sorry? No, that's you have to figure it out. You have to make it. But you cannot include rational and irrational numbers. You cannot include a half. You cannot include 0, the square root of 2. You cannot include those numbers. Because I said only integers.
So the whole process also needs to be integers, not only the answer.
Correct. So your set of numbers starts at 1, 2, 2, 3. This is the answer to that question. 1, 2, and 3. If I do 4, 3 times 4 is 12. Is above 10. So that's wrong. So this is my answer.